This video is about sampling at wastewater treatment facilities. It will show you how inspectors should prepare for a compliance sampling trip, review proper procedures for taking wastewater samples, and show you how to evaluate an NPDES permittee self-monitoring program. This demonstration of wastewater sampling is at the Massaponax Wastewater Treatment Plant in Spotsylvania County, Virginia. There are several reasons for sampling a facility's wastewater. One is to find out if the permittee is in compliance with its effluent limitations and permit conditions. Another objective is to verify that the permittee's own sampling and reporting program is accurate. Compliance sampling results can also be used in enforcement proceedings. All of these sampling objectives require that the inspectors responsible for sampling are properly trained and know the proper sampling and sample handling techniques. Without proper collection technique, even the most precise laboratory analytical tests will not yield accurate results. Ideally, the first step to a successful sampling trip is to prepare a sampling plan. This involves becoming familiar with the plant and processes before you get there, so that you bring the proper equipment, identify where to sample, know what parameters to sample for and how, and any safety precautions you should take. One good place to start is with the plant's permit and compliance files. These files contain the facility's NPDES or state permit, the permit application, recent discharge monitoring reports, and the results of other inspections and compliance sampling. The file should also tell you about any important changes to the facility or enforcement actions that may warrant special attention. The permit file may also contain descriptions and photographs of the waste treatment process used at the facility. Familiarize yourself with this information ahead of time so you can properly plan for the sampling trip and save time during your visit. The more you know about the plant and any compliance problems before your visit, the more efficient your data collection efforts will be while you are there. The permit also tells you the locations where the facility is required to sample. Some facilities are required to sample influent as well as effluent. As an inspector, you must be familiar with these details so that you can assess compliance with permit conditions. Proper sample location is also critical because you should sample at the same place that the permittee samples, and make sure that the sampling point provides a sample that is most representative of the wastewater being discharged. The permit tells you which parameters or pollutants to sample for and what type of sampling is required: grab samples, composite samples, or continuous monitoring for pH and flow. The permit also sets forth how often the permittee has to sample for these parameters, usually monthly, weekly, or daily. This facility is required to measure its flow, 5-day biochemical oxygen demand, total suspended solids, pH, dissolved oxygen, fecal coliform, total phosphorus, total nitrogen, ammonia nitrogen, and oil and grease, all at outfall 001. In addition to these parameters, the inspectors will take samples for metals analysis. Each of the parameters that the inspectors will be sampling for is recorded in the sampling plan. Also note the typical average daily flow from the plant. As part of your inspection, you will need to verify that the permittee's flow monitoring equipment is taking accurate readings and that the facility is not exceeding any flow limitations. Also check the files and former inspection reports to see if there are any special safety considerations that will require additional personal safety equipment such as a respirator. It is a good idea to talk to wastewater treatment plant personnel and other inspectors who are familiar with the facility before your trip to be well prepared and to avoid potential problems. Inspectors should not enter any confined space unless they have been properly trained and have appropriate safety equipment. You should always bring gloves, safety goggles, and wear proper clothing such as long pants and steel-toed shoes in plant process areas. Wear a hard hat and long-sleeved shirts when working in process areas or areas with heavy machinery or potentially harmful chemicals. Once you identify which parameters or pollutants you will be sampling for, you should familiarize yourself with the proper sample collection techniques for these parameters and record this information in the sampling plan. 40 CFR Part 136, the NPDES Compliance Inspection Manual, and the Compliance Monitoring Inspector Training Sampling Module specifies what type of sample containers are appropriate for the different pollutants you will sample for, how to preserve the samples, and how long samples can be held or stored between the time they are collected and analyzed. Also figure out how much wastewater you will need to collect. Sample volume depends on the type and number of analyses needed. You should collect more than enough sample to perform all the required analyses, including laboratory quality assurance, quality control. It is also a good idea to check with the laboratory to determine the sample volume needed for analyses. Sample volumes for specific parameters can also be found in the NPDES Compliance Inspection Manual and EPA's Handbook for Monitoring Industrial Wastewater. Sample containers must be made of chemically resistant material that does not react with or contaminate pollutants to be measured. Glass containers are required for certain samples such as oil and grease, phenols, and some priority pollutants. For pollutants that can be collected in either glass or polyethylene, polyethylene containers are preferred because they are less likely to break. Teflon lid liners are required when sampling for organic pollutants. Amber-colored bottles should be used when sampling for parameters that break down or oxidize when exposed to sunlight, such as cyanide or phenols. For this trip, the inspectors will bring sample bottles for 5-day BOD, TSS, metals, and nutrients. These containers were shipped from the laboratory that will be analyzing the samples. Make sure your sample containers have been properly cleaned to prevent contamination and inaccurate results. The specific cleaning and preparation needed depends on the type of pollutant being sampled. No matter what you are sampling for, you may need to take blank samples for quality assurance purposes. These are samples of water that the lab will analyze along with the wastewater samples to detect any evidence of contamination. There are 3 types of blanks that you may need to take: trip blanks, field blanks, and equipment blanks. Trip blanks are prepared at the beginning of the trip or by the contract lab by pouring reagent water into a sample container. This blank stays with the other containers throughout their sampling event and are analyzed for any contamination that may occur during transport to and from the site. Field blanks are prepared at the sampling site by pouring reagent water into a prepared sample bottle and handling the sample as all other samples are handled. Field blanks indicate whether any contaminants were introduced during sample collection. Equipment blanks are used to detect contamination by sampling equipment. Reagent water is run through a clean piece of equipment and poured into a prepared sample bottle. All blanks and samples are analyzed for the same pollutant parameters. The inspector also needs to check and calibrate the sampling equipment needed for the trip and recharge any batteries needed to run the equipment. Calibration should be verified in the field. Proper planning and coordination with the laboratory that will analyze the samples is another step to take at this time. This may involve obtaining coolers from the laboratory, tamper-proof seals, mailing labels, and any shipping labels needed to transport the samples to the lab as quickly as possible. Also review the QA/QC procedures and tell the laboratory when to expect the samples. If the samples are to be shipped by overnight express, check to be sure that this service is available at or near the wastewater treatment facility. Also, make sure that samples will be shipped in compliance with the Department of Transportation regulations. This is a compliance sampling inspection, or CSI. Thus, samples will be collected to monitor the permittee's effluent for the parameters limited by the permit, and to verify that the permittee's own self-monitoring program and sampling procedures are accurate, representative, and complete. Our inspectors are ready to go to the wastewater treatment plant and conduct their sampling. This wastewater treatment plant is a secondary treatment facility handling millions of gallons per day of wastewater. The plant uses physical and biological processes to treat the wastewater prior to discharging it to the receiving stream. Proper sampling techniques are critical, both for a facility's self-monitoring program and for compliance sampling by the control authority. An important part of sampling is making sure the location you take your sample and the technique you use provides a representative sample, which reflects the actual conditions or quality of the wastewater and is representative of the entire discharge. Once you have determined the representative location, sample where the flow is turbulent and well mixed, and where the solids have not accumulated. Do not sample from stagnant areas. the bottom of the channel, or skim the surface of the waste stream as this inspector is doing. Try to sample from the middle of the stream, with the container facing upstream. This location is where turbulence is highest and where solid settling is at a minimum. If you determine that the sampling location specified in the NPDES permit is not the most representative place, you may want to sample both there and where you believe the flow is representative of the actual discharge. Document what the problem was and exactly where you sampled so the permitting authority can correct the problem. If there are percent removal requirements in the permit, you will have to sample both the effluent and the wastewater influent points. When sampling at the plant influent, be careful to sample upstream of any recirculated waste streams. For example, sludge or supernatant is commonly rerouted back to the primary clarifiers. If the facility takes its influent sample downstream of where these recycled streams enter, the percent removal calculation will not be accurate. The facility should sample at the plant headworks in the area of the bar screens and grit chambers. Inspectors usually do not analyze the samples during an inspection, except when measuring parameters that cannot be preserved, such as pH, temperature, and dissolved oxygen. Here, the inspectors are measuring the dissolved oxygen levels and temperature of the effluent with a DO meter. There are two basic sample types: grab samples and composite samples. The type you use depends on what parameter you are sampling for and what type of sample the permit requires. At this facility, the inspectors will take grab samples for oil and grease and fecal coliform. Grab samples tell you about the concentrations of pollutants at the instant you take the sample. If the quality of the effluent changes a lot over the day, this sample is not representative of the average effluent quality. So grabs are appropriate for batch operations or other situations where the waste stream does not change over time, or when measuring parameters that can't be composited, such as pH, temperature, dissolved oxygen, oil and grease, and bacteria. To get an accurate fecal coliform test, the sample must be taken directly into the final sterile sample container with no transfers and treated with sodium thiosulfate to remove any residual chlorine and cooled to 4 degrees centigrade. Avoid overfilling the bottle so that the additive isn't flushed out. Also, leave an air gap to facilitate mixing prior to analysis. Each time a sample is taken, the time, date, and who took the sample is recorded in the logbook, in addition to the sample ID number. If this hasn't been done already, a gummed label or sample identification tag should be attached to the container. Do not place the labels on the container lids in case the lid is separated from the container in the lab. Use waterproof ink when writing on sample labels, and tape over the label so it stays securely on the container. This prevents misidentification and provides the laboratory with the name of the sample collector, the sample ID number, the date and time of sample collection, where the sample was collected from, and any preservatives used. Tamper-proof sample seals should also be used to protect the integrity of the sample from collection time to analysis time. The seal should contain the initials of the sample collector, the date and time of sample collection, and the sample ID number. This facility is also required to take 24-hour composite samples for BOD, TSS, and nutrients. Composite samples measure the average characteristics of the wastewater over the entire sampling period. This type of sampling is appropriate when the wastewater characteristics or flows are highly variable. Composite samples are made up of individual aliquots of sample. Two main types of composite samples are flow proportional and time composites. Samples can be collected as discretes, which are later composited based on flow, or they can be collected directly into a large volume container. These inspectors are setting up an automatic sampler to take a flow proportion composite sample over 24 hours. It takes discrete samples or aliquots at equal time intervals and puts them into 24 polyethylene bottles. This sample will be analyzed for BOD, TSS, and nutrients. The sampler is packed with ice to preserve the samples by keeping them at 4 degrees centigrade. Care should be taken so that the ice is not introduced into the sample containers. Clean plastic tubing is measured and attached to the sample probe and securely fastened to the sampler. Then the sampler is programmed for sample volume and time intervals for the automatic sampling. When the sampling period is over, the inspectors will turn the sampler off and pour a flow-proportioned aliquot from each bottle after shaking it to mix sample contents to make up the composite sample. The inspector views the flow meter recordings and calculates how much sample volume from each of the individual samples is required to make up one large composite sample. Higher flows during 1 hour justify proportionately more sample volume from the sample collected during that time period to make up an accurate composite. This sample is then split into the proper sample containers with any needed preservatives for transport to the lab. Sample preservation is important because some parameters change when exposed to heat or light or air, and immediate analysis is not usually possible. Three main types of preservation are cooling, pH adjustment, and chemical fixation. Cooling to 4 degrees centigrade suppresses biological activity and reduces volatilization in the sample container that would alter the sample results. This means that some samples need to be preserved in ice between sampling and analysis, including transport to the lab. In other cases, it is necessary to adjust the pH of the sample, adding nitric acid to keep metals in solution. Chemical fixation is necessary for certain parameters. Make sure that the preservative you use is reagent grade and is compatible with all of the parameters you are analyzing for in that sample. Preservation methods are also listed in 40 CFR Part 136. Even when proper preservation techniques are used, samples should be analyzed as quickly as possible. Maximum holding times for different parameters are also listed in 40 CFR Part 136. These times are the maximum times allowable between the time the sample is collected and when it is analyzed for it to remain valid and represent the quality of the wastewater. All of these details are important to be aware of so that the sample results you get are accurate and reliable. When the sampling is complete, the final step is to complete the chain of custody form and pack the samples up for transport to the lab. The chain of custody recreates the sample path from origin through analysis and provides a documented account of who has handled the sample. It is important if the sample results are to be admissible as evidence in any enforcement action. Inspectors should use a standard form that includes the following information: who collected the sample, the date and time of sample collection, the location of sample collection, the type of sample collected, any preservatives used for each sample, the name and signature of any person handling the sample in the field or laboratory, and any special instructions for analysis, including blank analysis. Remember to pack the sample securely and on ice if required. Use packing materials to prevent breakage. The ice will melt during transport, and the unprotected bottles may shift and break. The container the samples are packed in should be sealed and labeled. Reviewing a permittee's self-monitoring program is another important reason to sample. This review should confirm that sampling and flow measurement equipment are provided as required in the permit and that they are properly operated and maintained. For example, the inspector should check that self-monitoring samples are taken at locations specified in the NPDES permit and at the proper frequency. If sampling using 40 CFR Part 136 procedures is performed more frequently than the permit requires, make sure that they are reporting these results in their self-monitoring reports. This plant measures wastewater flows at a partial flume located near the plant effluent, just after the wastewater passes through the chlorine contact tank. It utilizes an ultrasonic level sensing device, which converts the wastewater level or head into a volume over time or flow rate. This number is read at the control panel inside the plant in MGD units. Check that the facility's flow monitoring system is taking accurate readings. Just as proper sample collection, preservation, and testing is important during compliant sampling, it is also critical that you check that the permittee follows the proper procedures to assure that the information that they are providing on their discharge monitoring reports is accurate and reliable. Also check that the permittee uses the correct sample collection method, either composite or grab, specified in the permit. Check that the samples are analyzed within allowable holding times, are stored in the proper containers, and analyzed according to approved test methods set forth in 40 CFR Part 136. Also check the permittee's chain of custody and quality control procedures. Common problems are that the plant does not keep copies of the chain of custody form, or that preservatives or time of sampling is not noted. And lastly, check that all their sampling and laboratory equipment is in good working order and properly calibrated, and that the personnel know how to use it. Interview the lab analyst to verify that proper analytical procedures are being followed. That about covers some of the important points of wastewater sampling. Here is a recap to refresh your memory. Prepare a sampling plan. Research the facility and plant processes. Identify and collect sampling equipment and containers. Review and implement QA, QC, and chain of custody procedures. Coordinate sample delivery and analysis with lab. Sample where actual condition or quality of wastewater is reflected.